Hi, and welcome to the Get Fruved video for analyzing Fruved data. This is an introduction to the statistical methods that we typically use when we're analyzing our data. My name is Kristen Rigsby. I'm a doctoral student at the University of Tennessee, and this video was prepared in conjunction with our statistician, Dr. Zhou, and our doctoral statistics student that typically works with us. Now, Fruved is a project with students, for students, to help students live a healthy and happy life. Fruved is happening at colleges and high schools across the nation. These are just the colleges that started the Fruved program. We have about 60 other colleges participating now, and we're expanding to high schools. Now, together, college and high school students are working to help promote health and wellness and change environments to help make the healthy choice the easy choice. The focus in Fruved is on health, healthy eating, being physically active, and managing stress, and really trying to encompass all aspects of life that impact our health. Now, as you may be aware, there was a survey administered at your school related to health behaviors. And the students in your school took a survey to let us know what their own health behaviors and thoughts were. Now, statisticians at the University of Tennessee worked with the data collected from your school and have provided the results for you to use in your own project. Now, why statistics? Well, statistics is important because it helps us know the difference in what we think is going on and what is actually probably happening. Now, the data collected from your surveys includes questions on dietary intake, which is also what people are eating, hours of sleep, how physically active people are, how stressed people feel, how much water they're taking in, are they helping with cooking at home, how often or when they eat meals, demographics, or also called characteristics of people taking the survey, which can include things such as grade point average, who people live with, gender, age. What factors make people choose different types of foods? How gardening may impact some of this, personality traits, relationships with others, and really importantly, how people feel about change in their school. What do they think is an important issue to change? What do they think about health in general? And if people have enough food to eat, which is also called food security. All of the specific questions asked can be found in the data dictionary we are providing to you. Now, a data dictionary is a document that lists all the questions and answers included in the survey. It allows for a quick and easy reference for researchers when they are running and analyzing statistics. You can look at these questions and think of different topics and research questions that you might be interested in. We are also giving you the results our statisticians found. You can use these results to decide the story you want to tell about what is going on at your school. And there are many different ways to tell that story. So, beautiful bar charts, a research poster. And don't think that art and children's books, and there are many other ways that can also display research. So don't count that stuff out. It is very important as well. So the purpose of this video is to give you a little behind the scenes of the statistical analysis that was done, what was found, and how it was interpreted. So let's start big. What is statistics and how do we use it? Well, first of all, statistics, we talked about earlier, tells us the difference in what is probably happening and what we think is happening. And one of the main things that we do when we do statistics is use statistical software to help us analyze the data. There are many different programs and formats, but in this particular case, we're going to be using a program called JMP or JMP, very user-friendly. Now, normally we start out with our data in an Excel file, which is shown here, and then it's easily imported into the statistical software. Now, I'd like to point out here that in the left-hand corner, we have what our data file is named, so we can see what data we have open. Here in the columns, we have the different variables that we have in this particular data set. And also notice this triangle and the bar chart here, it tells us what type of variable that is, and we'll discuss that a little bit further. Now, very first variable you see is participant ID. And what that is that ID is given to a student who fills out the survey. All of their name, personal information, anything that could identify them or their answers is removed from the survey. And we give them this number. So on each row, that one person, ID number 121, we have all the responses for questions or sometimes a score. So for example, here with NCI Fruit and Vegetable Score, it is actually a calculated score of how many daily fruits and vegetables in cups that somebody consumes based on a few questions they took on the survey. So once again, just pointing out that in each column is a different variable or a different thing that we are measuring. And so let's talk about what those variables actually are. And the way that we do that often is through data exploration. So first of all, let's think about these variables. There are two different types of variables, categorical and numerical. Within categorical, there are two different categories as well. The first one is ordinal, and so that means that there's a natural order to whatever the response is, with 0 having a meaning, and I'll explain what that means here in just a moment, a little bit better. And then the second one is nominal, so there's no value associated with each response, and there's no value to 0. So this is a really good example, the meal pat 1 at time point 1 that we gathered. This particular question asks how many times a day a student, or how many times per week a student consumes breakfast. And each response is a frequency. So 0 to 1 is the 1 response here. It's coded as 1. 2 to 3 times per week. And so whenever you think about what type of variable this is, we know it's a categorical variable, but we also know it's an ordinal variable because the term 0 has meaning here. So it has meaning in that 1 is a less frequency than 5, which is 4 or more times a week. Now, on the other hand, we have gender here, which is a nominal categorical variable. And the reason we classify it as that is because we have two different groups here, male and female. And there's no value associated with male or female. It doesn't indicate that one is better than the other, and there is no 0 value. So that's how we know it's a nominal categorical variable. And then we also have NCI Fruit and Vegetable Score, which goes into the numerical value. So there are actual numbers here that have value that represent something, which in this case is cups of fruit and vegetable daily. And so we have two of those variables here. We have one at time point 1 and one at time point 2, which in this particular case, it was that one was collected in the fall and one was collected in the spring, to kind of give you a perspective of how that may have changed between the same year, just from one semester to another. So when we're exploring our data, we're often looking at the data points and what is going on, where the data lies. And one of the things that we discuss is an outlier. So typically, an outlier is thought of as a data point that falls an abnormal value away from the rest of the data. However, when we think about outliers, we also think about what the variable means. So in this particular example, we are looking at the NCI Fruit and Vegetable Score, which remember is daily cups of fruits and vegetables at time point 1, so in the fall. And what we can see is that most of our data is grouped between 0 and 10 cups, which seems really reasonable, right? And we also know that most of the data is grouped there because of this box plot. And then the other points on the bar chart in the histogram actually tell us that those are potential outliers. Now, when we think about what those data points actually mean, what we're saying up here is that 2 different people responded that they consumed about 20 cups of fruits and vegetables daily. So one of the things that we do is we don't just rely upon what the statistical software tells us. We also think about how reasonable that would be for that particular variable. So in this case, is it possible to consume that many cups of fruits and vegetables? Sometimes we go look at the other variables and see, okay, are they vegetarian? Is any of their other data correlated in a way that we think this is a potential answer? And so these are things we think about when we think about outliers. Now, something else we look at with numerical values a lot of times when we're exploring our data early on is we look at the mean and the standard deviation. And so the mean, you may have heard of this before, is just the average of all the data points, so the central value. So in this particular case, we're looking at daily cups of fruits and vegetables again, and we see that the mean here is 3.22. So a little more than 3 cups of fruits and vegetables for 210 participants here. Now, the standard deviation is the amount of variation of the data set from the mean. So the standard deviation here is 3.42, and typically what that tells us is that most of the data lays about 3 cups above and 3 cups below that mean. And so we know that's where most of our data exists. So now that we've explored our data, we want to move more into data analysis, the fun part, right? So one of the first things that we often think about with data is how things change from time to time. And remember how we said that we had 2 variables, one for how many cups of fruits and vegetables were consumed in the fall, and then how many were consumed in the spring. Well, sometimes we want to know if there's a difference in that, and that can be a really important question. Are students consuming more fruits and vegetables at a later point in the year? And so one of the things that we have to do is we have to create a new variable to calculate that change. And so in the statistical software, we see that we have the 2 variables we discussed here at time point 1 and time point 2. And now we must create a new variable, which sounds really complicated, but it's not that complicated. So what we're going to do is we're going to create a new column, and we're going to name it NCI fruit and vegetable just to keep it consistent. But then we're going to call it change, and we're going to say the change from T1 to T2 because we want to be really specific. So when we go back and look at our data, we know exactly what we're talking about, making sure it's a numeric value as well. And then we have to tell it to do a formula. So we're actually going to say T2 minus T1. And now you have a whole new variable. So what each value in this new variable tells you is that from time point 1 to time point 2, this much change occurred for this particular participant. And then now we can actually look at it overall. So overall as a whole sample, how much change has occurred. And that's why we're looking at the distribution and that mean again to see overall has change occurred from time point 1 to time point 2. And so one thing that we often look at is the normal distribution. And so we look to see if the data is normally distributed, which is typically thought of in the bell curve format. And it shows that the data points cluster around the middle and taper off in both extreme values. So when we're looking at this particular data, our new change variable, we see a pretty normal distribution there. We can see that bell curve. We can see most of the data is gathered here in the middle. We see some outliers like we discussed. Now let's take a look at that mean. So the mean is negative 0.455. Now what that actually means in context, because the way we set up our formula, is that there is a potential that there is a change. So that's really important, right? But what we see happening is that potentially the change is a negative change. So students in the fall consumed more cups of fruits and vegetables than they did in the spring. And that standard deviation that we talked about before, 2.93. So once again, we can see that it's a pretty normal distribution there. Now, say we want to take this a step further about knowing whether or not there's a change in the cups of fruits and vegetables from fall to spring. So we're going to create a hypothesis. We're going to say, okay, so we think there is a change, But remember, it could be positive or negative, so we're just going to say there could potentially be a change. And now one thing we may want to do is see whether or not this change is significant or not. And if you've ever heard of a p-value, what a p-value is one way that we check to see if there's significance. The p-value is the calculated probability that your hypothesis is true. And when we talk about significance, what we're actually talking about is that the likelihood that the relationship between the two variables we're testing is caused by something other than random chance. Typically, when we talk about significant values, we're talking about it being 0.05 or less, okay? So going back to our research question, how do the cups of fruits and vegetables change from fall to spring? So once again, allowing for that positive and negative, and we just want to know if it changed. We think it might have, but let's actually do a test and see. So we have our new variable here. All right, and what we're going to do is we're actually going to go ahead and look at the distribution again, because that's how we actually run the test through here. So we're just going to bring over that variable. There's our distribution, same thing as before. And then one thing we can do is click on this and we can ask it to run the test mean. So testing the hypothesis that the mean is 0, meaning there's no change, right? And so our hypothesized value is 0 down here, but we see that our actual estimate is that mean that we saw before, which is negative 0.455. And then that gives us a t-test statistic here, which is negative 1.89. And we do have some probability that that p-value, again, a significant difference, that is less than t, because it is negative 0.03. So we know that there is a significant negative change. So we were just looking at one change variable. Let's talk about more than one variable and comparing those variables. One thing that we do with numerical variables is we sometimes look to see if there's a difference in the numerical variable by comparing it between two groups. So you've got a numerical variable and a categorical variable that has groups in it. And we want to know if they're same or different. And once again, it can go positive or negative. So the test that we typically run is called an analysis of variance, or an ANOVA. And the categorical variable there must have 2 or more groups to be compared. So let's do our hypothesis question. Let's say, sticking with those fruits and vegetables, is there a difference between how many cups of fruits and veggies males and females ate in the fall? Right? So we know potentially now that more fruits and vegetables were consumed in the fall, so let's focus in on that. And is there a difference in males and females? So our independent variable is our gender, because we have those 2 groups, male and female. We want to see the difference. And typically, dependent variable is thought of as the outcome. So we're looking at those fruits and vegetables. So your dependent variable is your numerical value. So let's go ahead and see how this looks in that statistical software. All right. So we can see we've got our gender variable set up here as a categorical variable. I'm looking over here. You can see the bar chart says, okay, I've already got it set up as a categorical. The triangle tells you I've got it set up as continuous for fruit and veggie. Very important to have those set up as proper variables in your statistical software. We're going to go ahead and move gender over to the X factor because it's independent, and fruit and vegetables over to Y because it's dependent. Just click the OK button. Now this is a scatter plot that gives us an idea of the distribution of our actual data. Let's tell it to run the test that we actually want it to run, which is the ANOVA there. All right, and so what we see here is part of ANOVA is that it also runs a t-test, but what we're looking for is that analysis of variance, and that p-value is 0.72, okay? So what does that mean? Let's do a little closer look there at the type of output you're going to get from it. Now, because we observed that p-value is 0.72, we can conclude that there is not a significant difference between the amount of fruits and vegetables males and females ate in the fall. So that particular grouping, that gender grouping, doesn't really help us define fruits and vegetable cups. Now, what if we had 2 categorical variables and we didn't have that numerical? Well, the test we run for that is called Pearson's chi-square, and that's looking at the difference between 2 categorical variables. So are they the same or different for each group of categories? And so one good way to think about that is there a difference between breakfast patterns for males and females in the fall? And remember, we previously talked about that variable, meal pat 1, that was set up in ordinal categories about how often somebody ate breakfast. And so that is our dependent variable. So categories of how often eating breakfast, 0 to 1, 2 to 3, and it's actually coded as a number. And then the independent variable, again, being the two groups, male and female, as gender. So very similar to what we ran previously, we are going to click the Analyze button, making sure our variables are set up correctly. It's once again very important. We're going to move over meal pat 1 to the Y response, and we're going to move over gender to the X factor. The first thing you see here is a mosaic plot, which, similar to the scatter plot, gives us an idea of how our data is distributed between the two groups. And then we have a contingency table, which actually separates each group so you can see how many is in each group. And then we look down here at the bottom for our test statistic, which in this case is the Pearson. So it's telling us correlation. And just a little closer look here. So for each group, so female horizontally, we can see that 1 being 0 to 1 times per week, 11 females reported that they ate breakfast 0 to 1 times per week is how we read that. And then we know that 9 males reported they eat breakfast 0 to 1 times per week. So a total of 20 males and females, 10% of our total sample reported 0 to 1. We know our total sample is 197 from here. And then our Pearson is 0.0076. And a lot of times it'll turn up these nice pretty colors when you do have significance. So because we are less than 0.05, which is our significant p-value, we can conclude that there is a significant difference between how often males and females ate breakfast in the fall. However, let me point out really quickly, we know there's a significant difference somewhere here in this table, but we actually have to do further statistical testing to determine where that difference is. So is it between males and females in the 1 category, males and females in the 2 category? We're actually not really sure. This just lets us know something significant is there. All right, so that concludes the big statistics video. And I want to point out that this is just the basics. We have just brushed the water of the surface of the lake here. But if you want to dive in deeper, we can definitely help you with that and take a look at the data, ask questions. And as always, if you do have additional questions, if you want more information, please get in contact with us. Let your teacher know, let your Fruved contact at your school know, and we would be happy to help you out. Thank you so much for watching.